Welcome to 5.5 number 1 video. This is taking place of Tuesday's class. Today we are going to be learning how to solve exponential and logarithmic equations. And so our objectives today are just to learn how to solve both of those types of equations. When we are solving exponential equations, there are two main properties that we want to remember. And these properties are basically saying the exact same thing. It says if a to the x equals a to the y, in other words, the bases are the same, then x equals y. Over here we have log base a of m equals log base a of n. If the log has the same base, we can get rid of that log and m equals n. So we are just going to be solving these equations during this section both algebraically and graphically. We can solve the equation algebraically and then verify it graphically. And in some points we will actually be solving the equation graphically, especially if it's one that is more difficult. If you see algebraically, that means I want you to solve it algebraically. So you need to be able to do this both ways. So in example 1, we have 9 equals 2 raised to the x plus 6 power. So the first thing I want to note is that there's no way that I can write 9 as 2 raised to some power. So I can't use that base exponent property that I want to use. However, I can take the log of both sides in order to bring this exponent of x plus 6 down. So what I'm going to start out by doing, my first step is to take the log of 9, and then I'm going to take the log of 2 raised to the x plus 6. Well, you know that when you take the log of a number raised to a power, that power comes, that's x, comes down in front. So now we have log of 9 equals x plus 6 times the log of 2. So now x is down, no longer in the exponent, so we can just solve it like a normal algebraic equation. We're going to divide both sides by the log of 2. And when you put that in your calculator already gives you one parenthesis. Don't forget to close that parenthesis or you'll get the incorrect answer. When you take log 10 of 9 and divide it by log base 10 of 2, you get 3.1699 ... Now remember, even though I'm writing down a number on my paper, I'm actually keeping that entire decimal in my calculator because you never ever round in the middle of a problem. So this equals x plus 6. So to solve for x, all we're going to do is subtract 6 from both sides. So now we have negative 2.830 equals x. So the next thing we need to do is we do need to check our answer. And so when I go to check my answer, I'm just going to plug negative 2.830 in for x. So I have 9 equals 2 raised to the negative 2.830 plus 6. That's a plus sign. There we go. And when I plug this right-hand side into my calculator, I get 9 is approximately equal to 9.000467. So that's really close. Remember, we've rounded, so when we round, we're just looking for them to be approximately equal. So this works out. So we solved that correctly. Now, if we look at this other problem, in B, we have 5 times e raised to the 6x plus 2, then below 8 plus 8. So what we want to do is we want to get the e raised to a power all by itself before we start doing anything fancy. So I want to get rid of the plus 8 and then multiply by 5. So the first thing I'm going to do is subtract 8. So I have 5e to the 6x plus 2 equals 12. Now I'm going to divide by 5. So we have e to the 6x plus 2 equals 2.4. And that's a terminating decimal, so it's just 2.4. Now, if I want to undo e, I can take the log of both sides. However, to save myself some time, I'm going to take the natural log because the natural log is base e. And I'm going to bring down my power first. I have the natural log of e equals the natural log, because if we take the natural log of one side, we must do the other, of 2.4. Now, hopefully you recognize the natural log of e equals 1. So really this is just 6x plus 2 times 1. So now we have 6x plus 2 equals the natural log of 2.4 is 0.8754 dot 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 dot. Remember, we keep that. Now what I'm going to do is I'm going to subtract 2. 6x equals negative 1.124 dot dot dot. And then I'm going to divide by 6. So x equals negative 0.1874. And I rounded that final answer. So if we wanted to check, I would put it into the original 5 e to the 6 times negative 0.1874 plus 2 plus 8. And that should be approximately equal to 20. And it is. So we did that one correctly. Okay? Now we're in C and D, we're still solving algebraically. These two are a little bit more complicated because we're going to have to use a method of substitution. Now you've done this before, so this shouldn't be anything too difficult for you. So we're still going to kind of look at this problem and see what we notice. So I notice I have an e to the 2x on this side, and I have an e to the x on this side. However, I have a plus 16, and because I have that plus 16, and not every term has an e to the x, I know that I can't use that base exponent property to say e to the x equals e to the x. So I want to get everything on one side. So I have e to the 2x minus 16 minus 6 e to the x. And that equals 0. Now I can write e to the 2x as e to the x squared. And I'm going to rewrite this as minus 6e to the x minus 16. That equals 0. I just like to have it in descending order. So what we're actually going to be doing here is we are going to be substituting. We're going to substitute e to the x, and that's going to equal u, or t. It can equal any variable. If I plug that u in, I actually have a quadratic function. I have u squared minus 6u minus 16 equals 0. And so this is a way easier problem to solve. We just need to factor this. So we ask ourselves, what two things multiply together to give us negative 16 and add up to negative 6? Well, hopefully you got u minus 8 and u plus 2. So then our two values for u are 8 and negative 2. But remember, we substituted in u for e to the x. So what we're going to do now is we're going to say e to the x equals 8 and e to the x equals negative 2. So we go ahead and solve both of those by taking the natural log of each side. And when you take the natural log of e, remember it's equal to 1. So we have x equals the natural log of 8, x equals the natural log of negative 2. And I know I didn't give you enough room here, and I apologize for that. So when you take the natural log of 8, you get 2.079. And when you take the natural log of negative 2, you get a non-real answer. So this one doesn't work. So this solution is extraneous. It's an extra solution, but it doesn't work. So our only solution is 2.079. And that's how you solve with substitution. We're going to be doing the exact same thing in letter D. Let's get everything over into the right-hand side. And remember, the way I knew I was kind of going to be doing this crazy stuff is because I had a constant plus, and then I had an e to the x on each side. So I want to start out with e to the x minus 1 minus 4 e to the negative x. And now because I have fake paper, I can erase some of this so that I have more room. Sorry for you guys who can't. And that equals 0. Now, I hope you recognize that e to the negative x, we can use that negative power property. We have e to the x minus 1 minus 4 over e to the x. And that equals 0. Now, I don't want an e to the x in the bottom. You never want a fraction with the variable in the bottom like this. So we're going to multiply both sides by e to the x. So this gives me e to the x squared, because we did e to the x times e to the x, minus e to the x. And then we're going to do e to the x minus times negative 4 over e to the x. So those e to the x cancels out, and we have minus 4 equals 0, because anything times 0 is 0. So now we're going to have to substitute again, and we're going to be substituting that exact same thing. E to the x equals u. And then we get ourselves a nice quadratic again. U squared minus u minus 4 equals 0. So we're hoping that we can factor. However, I can't think of anything that's going to give me, when I multiply together, give me negative 4 and add up to negative 1. So unfortunately, we are going to have to use the quadratic formula. And so if you remember that, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is not something that's new to you. So we are going to have negative b is 1 minus, or plus or minus the square root of 1 squared minus 4 times 1 times negative 4. And that's all over 2 times 1. So this equals 1 plus or minus the square root of 17 over 2. I'm not liking my thin pen. I was hoping it would help me write smaller, but all it's doing is making it harder for me to write. Okay, so going back to my normal pen. Remember, this is actually u equals, but we want it to be e to the x. So e to the x equals 1 plus the square root of 17 over 2. And e to the x equals 1 minus the square root of 17 over 2. So then, how did we solve last time in C? We took the natural log of both sides. So I'm just leaving this because I know this isn't pretty. So I'm going to put it into my calculator. So in my calculator, I just take the natural log of this, all of this junk. 1 plus the square root of 17 over 2. And that gives me 0.904. And then I'm going to do the same thing, the natural log of 1 minus the square root of 17 divided by 2. And remember, if you're putting this into your calculator, don't forget to put parentheses around the numerators. And that gives me a non-real answer. And that's because negative numbers are not part of the domain of a logarithmic function. So our only answer here is 0.904. Once again, I apologize for not giving you enough room to solve that. Hopefully you are able to write smaller than me. So we got that 0.904. Okay, let's go ahead and erase this. Okay, let's try to get example 2 done before my video time runs out. So in example 2, we are going to solve using our graphing calculator to approximate the solutions. So the way that you are going to do this is you are going to put y1 equals e to the 7.2x and y2 equals 14.009. Now it's really important that our window is appropriate. So your window, when you go to graph this, you're going to have an x min of -1, x max of 3, a y min of -1, and a y max of 20. Now I know I need to go in my y's at least 14, but it's nice to go somewhere above that. Then once you have this graph, you just do second, trace, and intersect. So once you've done that, it's going to have you choose the first curve, which is your y1, so just hit enter. The second curve, which is your y2, so just hit enter. And then enter one more time. So you're going to hit enter 3 times. And remember, all we care about is the x value.